Hi.
Sorry, I'm late.
No, do you hear me?
I hear you fine. Yep.
Ah, cool. So it's okay. Do you see this screen?
I don't see a screen right now. All I see is your avatar.
Okay. So share screen, entire screen. It doesn't let me show this one. Okay, maybe I can try this. Sorry, huh?
Take your time.
It seems that you see it.
Now I see it. Yes, sir.
Okay. So if I do that, you see something switching.
Yep, I see something switching. Yep.
Okay, perfect. So we wait a little bit now.
Yeah. Do you want us to go live or do you want us chill out and backstage for a little bit longer?
No, we can stay live.
Okay.
Drew?
Yes, sir.
Yes, do you think we go or we wait a few more minutes?
How about let's start now? 10:05 seems like a good time.
Yes, perfect. So we start now. So hi everybody. I'm really happy to be with you for another live. How to start? Yes. So To tell you a little bit what we're going to do today, I got some feedback last time, so I will incorporate some changes just to make this live maybe a little bit engaging together. So we are going to split the live in 3 parts, each I hope of 20 minutes each, or maybe 25. And at the end of each part, I will stop and go to the chat. And if you have some question at that moment, we can talk together 5-10 minutes. And the live will be no longer than 1 hour and a half. So if we can't do everything, I will do the end in a video at home, and I published it on the LM Room and in another moment. So this is for the plan. And now let's see what we are going to do. So last time was really about understanding using Python, but understanding how the plugin system works when we want to add a JSON-RPC method to Lightning D. So today we are going to add the same method to build the same plugin, but using pyln-client Python package. So it's really faster, because almost all the plumbing is done really well by this library. And this library uses Python decorators. So maybe you know about, maybe you don't know, but I think that this is a good moment to go through 2 examples of how decorators works, and the second one is really tight to the way it is used by pyln client. So at the end, if we have time, we are going to look the plugin.method that is done provided in pyln client, and how it works. So it uses decorators. So this is why we see decorators before looking at the implementation details. So in 20 minutes, normally you are going to be able to write your own Lightning plugin. So this is the main part, and after we're going to go into the details. So let's go. So it is 5:08, and we'll go for 15-20 minutes. So the game. So here we're at the first line that I'm here. So maybe you see what I'm showing, and this is the way we start a plugin that we are going to call here myplugin.p, and we are going to pass it this option at starting. And what we want to accomplish is when we call it with the key foo1 equal bar1 and foo2 equal bar2, what we want to have is this response, this JSON, where we see the node ID of the node we're running. We want to have the option that we passed at starting, and we want also to return those parameters. So it's not fancy. It's really to get all the parts and how we do it with pyln. So let's go to our terminal to be sure that you can reproduce, or we can agree with my setup. So I'm running Lightning D 23.022, Python 3.10.6, and I'm on Ubuntu 2022. So here in that Lightning, so this is a repository of the core Lightning, and we have this startup script that gives us the possibility to start several Lightning nodes running on the rec test chain. So we are going to work on that. So you see here Lightning B and Lightning CLI, and now we can start. If we just do that, we're going to start Bitcoin Core on rec test, and we are going to also start two nodes, one that we can see here. So to see the alias that we have is this one. So you see at the end of the line, we have the Lightning there in which the settings and everything happen is temporary, and one of rec test. So let's see what we have here. So I think I didn't I plugin. So I didn't wanted you to see that. So sorry, I did it before. So here is how we are going to. This is the plugin that the basic skeleton of the plugin. We get the plugin class from pyln-client. Here we declare the instance plugin, and there we run the plugin. We are going to see after what does that mean to run. But this is what we have to do to get something working. And there, this is where we are going to add to declare the method that we call myPlugin and also the option. So let's go back to our terminal and try to start that that plugin. The file. So we have it here. So I can do -l. We have it here at that line, so it is already executable. So we can try to start it. So L1 CLI plugin, and we want to start. We have it here, and this is my plugin.py. So here we see something. First error. So as we did last time, I do errors sometime first to show how the system answers back and how we can go with that answer to know what to do. It's a kind of a guide. So here we can see no module name pyln font. So this is normal because I want us to do it. And what we're going to do now, it's to call it in to add it in a virtual environment that we call it VAM. So here I defined we define a virtual environment where Python is going to run on. We source the files that are in virtual environment, bin, activate. So we have that. Now we are in the virtual environment, and we can check it. That, for instance, if we do which Python, so maybe you already know that, but it's just that we are targeting that that Python binary. So now we're going to install. So pip install. We want to install pyln-client. So let's see. It's working. Maybe we can list those things. This is the first time that we do it together, so maybe we can just show a little bit all of those things. So when we get a pyln, we get a bunch of stuff here on the pyln. So now that we have it, we can try to start again our plugin. So now it should work. And sorry, I'm missing something. No module name pyln. So I did it just before. And what do I'm missing? This is what we have. So I'm looking for the answer. I don't know what I'm doing wrong right now, and it's funny because we got lucky at the first live, and everything went perfect. So, module not found error. So why is that? Line 3, this is this one. Let's deactivate to see if maybe to see L1 up here plugging. We want to start that plugging. So this one is normal because we don't have it. I don't know. Let's do it again. So bind bind activate, and why would that work? Because I'm doing the same thing. So okay, so I will do something different. So which Pythons, maybe this is going to work. So up, so we have that. Maybe we can do something like that. So we directly target the Python that we want. We deactivate this one, and now we do that. Okay, so better. So sorry for this moment here. I don't know why I'm when I'm doing that what I was doing before, but anyway, where at the top, if we passed the binary that the Python binary that we want, it will catch it and recuperate the module that we want. So let's continue, and this is. So now we can see here the message that we get is exactly before replying to a get manifest. So this happened because we had this part that were commented. So we were just importing plugin, but we were doing nothing. And the basic to recall that how the plugin works is that here we have a client that do something that when we start that say, hey, Lightning B, please, I want to start the plugin, and the first step here is to go to talk to the plugin and to send the get manifest. The plugin receives the get manifest, and it say, okay, I want to declare those methods, and I want to declare maybe some hooks, anything. So he return to Lightning D the response, the get manifest. Then Lightning D say, okay, now we did the get manifest request. Now we are going to do the init request, send the init to the plugin, and the plugin send it back the init, and then the communication continue. So we didn't have it here. So normally, as we've saved that, this is going to work. So now we have it listed. It should work, and we can check that by looking for a process that has my plugin in its name. So we have it. So right now, this is the plugin is running. But if we try to do something, so things start to get interesting. Now, what we want is really to define a method, my plugin, this one. So here we go there. If you look at closely at the plugin, there's no appearance of my plugin. So we are not declaring that method yet. So it doesn't, this is not going to work. Let's see the error. So this is exactly what we wanted. Lightning D talk to the plugin, say, hey, do you have my plugin? Because maybe you might have it. Doesn't have. No, it's not, no. It even talk to. It just say that I don't have my plugin registered. So it right now we are at that point. So let's see. So okay, so yes, as I said, we are going to see after plugin run a little bit of how it is implemented. But as I told you that in 20 minutes you'll be able to write a plugin. This is what we're going to do. So now here is how we declare the method, and the method we call it my plugin. So what we are going to do here, this is the name that we want. If we look here, this is what we want to have when we call it. So the name of the method, and here this is a function that is going to be in charge of giving the answer and the result to Lightning D when we call my plugin. So here, to distinguish really that what we are going to do is a function, and there often you have the same name as the method, but this is not answers, because this is just the function that we want to use to answer. So what we can do now, we want to return some response, and we can say, for instance, foo and bar. So now we are defining. So we have that function. Here it takes the plugin instance. We are not using it inside the function, and we just return an object. And writing this with decorators, we are declaring that method in the list of the method known by my plugin that will be declared in the get manifest. And then here, when we run and when Lightning D say, hey, you say that you are going to handle my plugin method, do something, and the thing that is done is here. And pyln-client is fantastic and do all the job for us to do the answer and to treat the thing well and deal with the communication. So here, what's really interesting is that we even don't have to know that we are doing stuff with input and output of our process. So this is I think fantastic. So I saved, and now we saved, and now first we have to stop the plugin. We're going to start it again so it works, and now we call my plugin and we should see toolbar. So I just let it a little bit in the screen. And now, if we go back there, you know, you already have a plugin. So we have already defined an RPC method, JSON-RPC method that we register to Lightning D. So this is all you have to write to do the thing. Now, remember that what we want is to have all those things. Okay. So first, let's treat the case of the options. Okay. So the options that we passed when we start our plugin. So we go back to my plugin here, and here what we call it foo opt. So we did this like that, and the funny thing is, okay, because every here when this is running, all the option on the methods that we've defined before are known by the plugin instance. So here what we can do is to get option, to get the option, and the option that we want is foo opt. So we are going to do that, and we are going here directly to pass the answer there. And I have a question for you. I will let you think about it. Do you think that this is going to work? Okay, well, I'll let you think a little bit. And we're going to see that no, right now it's not going to work. This is the right syntax, if I'm not wrong. This is the right syntax. It's not about the syntax, but we're going to see the message, the error message that we get. So here, again, we stop, start, we have it, and let's call it. So one thing before we call it, when we define something, if we made an error in that function at the starting of the plugin, we don't catch it because we are not calling that function. So we are not doing stuff that make errors. But now we've seen before that with that syntax we correctly add the method to Lightning D, and now we can call it. Okay, cool. So more error, more thing that we learn. So this is something that we should expect. So the message error while processing by plugin, no option with name foo opt registered. So this is what we know. We didn't register it, and we want to use it. So it won't work. You have the traceback. What we did now, it's a simple error in the sense that we do it because we wanted to do that error. But to see you have the traceback, we can here fire Python and print that traceback, so you can see it better. So this is what you will have get here, and the error that we have is here. Foo opt, the plugin get option foo opt in line 9 in my plugin function. So we can go to line 9, but as I just said, this is something that we did purposely. So this is our fault. So now, no problem. We are going to plugin and add the option. So we give it a name. The name that we want is foo opt. We have to give it, or I'm not sure, maybe we don't have to give default, but let's give it some default value. This is bar, and we are going to give it a description, but I think that the description is mandatory. So maybe we can write it this like that. Foo opt descriptions. We have it. We just saved the in the file. We go back to our terminal. We stop and start the thing here. Before replying, okay, so we did maybe some error there. So let's read correctly the error. Accepted before replying to get manifest. So that means that there's something written wrongly there. Just let's say if we remove that. So stop. Start it. So it's working. So something is happening at that level. So let me see. Maybe I think this is default. No? So let's try it again and start. Okay. So typos. It happened. So definitely it just happened to me right now. So this is something that I should have catch, but here it is. So what we can learn from this typo is that if you do something wrong here before entering in a plugin.run, what happens is that you're more likely to get the error that we get. That was here. We go back. Do you have it? And this is okay. This is that one. Now to know how to catch the kind of error that can happen. Now this was a typo, but it could have been another kind of error. And if it's not done inside the method, we don't get the beautiful tracks back that we had before. But before replying to get manifest, that means that we didn't enter in the run IO loop. Okay, so here for the listen, and okay. So normally, as we started it, we should have here something that return bar. Okay, so we have foo opt and bar. We can we might be happy, but yes, we are happy for what we just did. But let's give it another option at the start, at the moment we start the plugin, to see if some things happen, because now maybe it just it is catching the default, but let's see if it works correctly. And we go back to the note here, and we take that that command line. We go back here to terminal here, and first what we want to do is to stop the plugin as it is working. We passed that one, and you see at the end, this is the important part, the end where is the cursor, foo opt equal bar, and at the beginning we have dash k. So dash k is when we want, or we have to pass key value pairs in the command line, and for starting the plugin, it is mandatory to use the dash k to be able to use the option at the end, the foo bar. So we start it like that. It seems to have been started correctly, and now we can catch, and we should have bar in uppercase. And this is what we have on the first step. So we've just spent 25 minutes doing that. We are almost done for the first part, and now let's get rid of the result that we have. Take we go back to the node. What we want is that JSON answer. So we have it here. We use a foo opt, okay? And in a moment, we are going to see how we can talk to our Lightning or to our Lightning node to get the node ID. And this is really fantastic, because we even don't have to know that we are going to we do a RPC call on top of a Unix socket, because it's just using the API is so cool. So we just call a method on an object, and it works. But now what we want is there. We want to get the parameters that we give at the command line. So let's go back to the terminal. We stop again. So last time I've used a little script to do it automatically, but as we don't have to do it so often, we use it like that. So it started with the new one, just to check. And now my plugin, so let's stop it and start it again. So what is it running? Yes, it is running, but for some reason, well, I don't know what I did. I went too fast, and it's not a good idea to go as fast, because error happens. So we are returning this JSON object, and now let's see in the note here how we can do something like that. So you see that we want to call with two parameters, two CLI parameters. So we do it, and now here we are in my plugin. So far, this is the function that is in charge of answering back to Lightning D to the call of the method myPlugin. Now, here we're going to add some parameters. So there are various ways to do those things here, but you will find out if you have some other use cases to do. But what we want us is to have two parameters that have default value if we don't give value at the prompt, and it will answer back foo1, foo2. So here in the parameter, so we can do something like that, foo, and okay, we have those, so it should be working. So we passed here. This is a plugin instance, because here, for instance, we used it to get the option, and we are going to use it after to talk to the our node. And here, these are the parameters that we are going to pass at the command line when we call the plugin, the method. So go back to term here. So we have to stop. We have to maybe start. And now we go back to node to copy and paste that command line. We passed it here, and we hope that it works. And we can be sure that it works, because here we have bar and bar one, and maybe let's do it differently again. R1, R2, and you see this has changed. So we are doing the thing right. Last thing that we want, this is the node ID. So we're going to call it node ID. It's not super fancy, but node ID here, and we use plugin, and in the plugin object we have embedded, if I can say that like that, this RPC object that come in pyln-client in the plugin in the Lightning, and I don't remember if it's Lightning or Lightning D, but anyway, it's here. This is where everything is implemented to have the thing, and I don't know if all the methods are defined there, but many are defined as instances of that object, not instances, but really method of an object. And before we do that, let's just see what we want. So we want to, when we get when the user, so let's frame it like when the user run that command, Lightning D say, okay, fine, you want the answer from my plugin method. This is the plugin, my plugin, that is responsible to get the answer. This is sent to the plugin, and the plugin there has the possibility, if you want, to talk to the node before answering. So this is what's going to happen, and the thing that is going to do, the plugin is going to do, is really to do the get info. So just call less to see everything. So at the first one that we have is the ID, and we can choose to have other thing if we want. And here to have it, so ID. So the ID is this one. So no params to pass to get info. So here, get info. This is a method call, and what we want, this is only the ID. This should work. So we just saved that. Here, we should have it in the returned result. Let's go back here, there. So we stop again. Stop. Start. We have it. Let's print out this node ID to be sure that we have the right node ID, and the one that we want is this one. Okay, so let's see if it is correct. And this is the one that we wanted. So my plugin here, and maybe I can just do something like that so that we can see everything in this. Okay, like this. So this is the plugin. So for the one that were that watch or came at the last live, it took us much more work to get this working, but pyln work like that, and this is super declarative, and this is brilliant in the sense that we don't have to know nothing about maybe almost nothing about the system. It's crazy, because just that, okay, so I give the name, so we are going to go there. So here I give the name to register this. Okay, what's going to take to answer this is my plugin, which is just a function that takes some parameters and some stuff that are in the object plugin. If we want everything is done to talk to the node, here is an option that we have defined, and we return a JSON, a dictionary, but mainly a JSON object, and we declare the option like that, and at the end we have this magic plugin.run that is fantastic. So we are done with the first part, and it took us 40 minutes. I was hoping that it was going to take 20 minutes, but it's fine. So I stop, and now you go to the chat and see if you have some question. and think that maybe I don't have the answer, but as we are 7 now, maybe other people have an answer. If you don't have a question, tell me too, and we can move on. Yes, so don't forget to install the French dictionary package alias ls. Okay. The question is, are there clients for other languages? So in the page of Lightning, so I know that that there are two for Go. That so let me, because here I'm here plugging, and maybe we can go to, no, it's not this one. See, plugin. So in the readme here, if you go to the repository of all the plugins, you have some information at the end here, where you can find the solution or information of plugin on client that do the thing. So here you have a plugin for Go by Nifty, and yes. So this maybe not the best answer, Clavo, but yeah, there are some clients out there. But if you were so you told me that you were at the last session, it's not, it works to provide the clients, but it's not so much needed. If you just want to make one shot plugin, and maybe you are not going to write more, well, you can you can do the stuff that we did last time, taking care of some edge cases what offer pyln. So if we can go to so this is a good question. So we can go to the code. So here we are, and we can do here. So still Valve. Why? Okay, Valve client. So here is the library as we got it from pip. And if you go there, so maybe we can do this and clock. You know, it's not big. Maybe I hope I'm not wrong in the calculus, but it's 2,000 line and really take care of many things. But maybe you don't need so much so much, because it handles a lot of stuff. So if we go in the plugin file, so just to show you, because I wanted to go there anyway before, so you can I don't know if you see in my mod line there, this is 1,000 line, and here we have some of the methods. So we have method tab, we have the method here, request, and we have the plugin. And if we just concentrate, so I narrow to just see the plugin, here are the functions that are the methods and the initialization that are done. So I don't want to say that it's not so difficult, but because it's always works to do, and it's better if there is other clients, but it is feasible without client too. I hope this is a satisfying answer. More question or we move on? Okay, question. I read in the correcting that plugin Lightning D communication steady inside out. One process writes RPC message to standard out. Another reads from its standard in. Does it give you best performance you can get on Linux system, or some alternative for such communication exist? So I have really no idea of the performance. So I'm not skilled enough to know exactly the performance. But last time we used, we really did the work of seeing the standard in and standard out, how it is working in the game of plugins. So exactly. So maybe we can go. We are still to stay with that question. I won't answer with performance because I really don't know. But here we have the method run. So I just narrow to that method, and here we really see what is going on is really what we did last time. And anyway, at some point, this has to be done by any client that is offered to work with the plugin, because it's really we are waiting and reading on our standard input, and Lightning D will send us notification if there are some notification to do, or the hooks, or the methods if we have to do stuff with those things, and we are going to answer back. So here really what we do is we get an here self. So this is from the instance of the object. stdin standard in is our standard in that you provide when you instantiate the plugin, or this is something that is the standard in that you get with your process. Then here, this is just we are going to grow partial. If we can split it with two new line, because this is our Lightning D send its messages at the end of any communication, any request or answer is with two new lines. So you can read that in the Lightning RPC main page, I think, or Lightning D. I don't remember. If we can't, we continue reading. Here, this is a continue, and there we do the multi-dispatch on the messages, and this is taking this is the plugin take care, the class plugin take care of dispatching following here by plugin the methods that we provided, are the notification of the hooks that we are not talking right now. Okay, so let's move on to the next part. So we are left 35 minutes. So let me just drink a little bit of water, and now go back to the note. And okay, so we did the first part, and the last part we are not going to do it. Look at plugin method implementation, but I will make a video on that subject before the end of in the week that is coming, just to really end this live, because everything goes together in a beautiful way, I think. So now we're going to look at the decorators, and maybe in the chat, can you tell me if you are familiar with decorators or not, so that I can see a little bit. Okay, so I continue. So the decorators, this is a mechanism here that we used with the @ sign. So the @ sign is just a syntax to do the thing. Okay, so but what's really what is decorators? How does it works in Python? So this is really Python specific. And sure. So I remove everything. I didn't want to show those stuff. So let's go. We are going to try to do it in 20 minutes. So, okay. Maybe first, why it might be important to know decorators. One way to think about that is that if you want to write plugins with pyln, it can help to do that. And another way to think about that is that the tests in Core Lightning are written with Python, and decorators are used with PyTest in the source code. So it might be useful to understand the mechanism, and we can go in the Lightning repository. And here I will do it there. So I have a UI in my editor that let me do a rip grep to catch some of the things, but this is something that you can do at the terminal. So we are looking, if you look at the bottom, so we are looking at all the file, all the line in every files of the Lightning directory that start with PyTest, for instance. Let's do that. So we can see that we have 448 it, and we can see that there, this is all over the places there. So it's really, I think that this is useful to know a little bit how it works, and we can go to one of the tests. So here we have one, so PyTest, so we can compose the thing, and here we have the test that we are going to do. And we are not going to do right now, but it's just to say that to motivate why it can be interesting to know a little bit about decorators. So decorators. So we are here, and I will start at the bottom. I have the Python interpreter, and I can send, so you can see at the top, if I write print to, for instance, and this send the answer at the interpreter at the bottom, so we can work like that. So let's go. So the thing is, the syntax is something like that. So we have foo that takes one argument, and maybe what we just want to do is that foo print. So we are going to make it print x here, x in. So we say that we are in foo. Okay, so we can do something like that, where bar is defined somewhere here. Okay, so this is the syntax of what we have, and when we run that piece of code, so maybe I will say evaluate, but it's not the right term. But when we run that piece of code, or we send it to the interpreter, we are going to define the function foo in a certain way that will modify it as if we were writing something like that. So foo bar foo. Okay, so really, when we do that, when we evaluate, and we have we still haven't say what is bar, but the decorators, this syntax and this mechanism is a way to transform that function, to redefine that function by using it in another function and redefining it that way. So, but we do it without writing this that phrase, but this is important to see it. So bar to be the kind of functions that we want, because foo here still has to be a function. So what does that mean? That means that bar, when you take an argument and we want it to take a function, it has to return when we evaluate it, when we run it, it has to return a function, and we want a function that takes the same argument as x. Okay, so let's see, let's define. So far, I didn't send nothing in the interpreter. Okay, so it's not abstract, but it's a bit, we're doing nothing here, but maybe we can just, no, I will follow this way, because I want really to do it in the time that we have. So foo. So we take a function, and now bar must return a function. So we could do something like that. So if we do that, we return f, and we take f, we return f, and so when we, I should have let this thing here, bar foo, but we commented because we don't want to evaluate to run it. So we could do something like that, but if we do that, we are not going to change the function. So let's see this. So you can see at the really bottom here in this area, we see what I sent to the interpreter, and in the interpreter something happened, but we just defined the f. We just defined bar. Maybe we can check what is a bar. So bar, it is a function. Okay, so I send it. This is a function. Fine. This is what we wanted to be. And here, what we are going to do is to send this whole those expression here. So we sent those things, and now let's see foo, what does it return? So if we see here what we did, we took foo, we apply it, we apply bar to foo, and we return foo. So the function normally hasn't changed. So this is what we see. It really does what we've written there. We print the argument in foo, in the body foo. Okay, now let's do something different to see different in the result. Maybe we can define here a function that is going to be a little bit different. So bar inner, because it is inside. We take x, which is going to be one argument here and one argument in foo. And let's, I will remove the interpreter right now. And what we can do is, okay, let's take that line, put it here, but now we're going to do that in bar inner. So let's call it bar inner. The interesting part, it may be that we want to apply that function. So you can imagine if we are doing some testing, this part might be something that that is a fixture, or that sets some variable, or that sets some of the things that you want to be able to live in the right environment to evaluate f the x. So might be used this way. But what we do, just we say, okay, we are going to do something that will print something, and we apply f, and this is what we want to do. And here we return. Now we no longer return f, but we return that function. Okay, so this is that function that we return that has the same number of arguments as our function f. So let's redefine bar. So is bar redefined? So we sent bar, and now we go here and we redefined. Did you read bar inner? So sometimes better to do it. So don't know what did happen, but we can send it again, and we send it again. So now it's working. So we have those two things redefined again. We just send that part, and if we evaluate through ln, I will let you a moment to think about what we should see. So remember what we did is that we applied bar to the function foo. This has returned a new function that is bar inner, and we have assigned that new definition of that new function to the name foo. So I hope what I'm doing, what I'm saying will be reflected with the result. So now we have that. So the function foo here is not only that part, because we applied it that things. Okay, so we can do it again if we want. So cln in bar inner and cln in foo, and you can see that this is exactly what we have here. Okay, so we did. So to summarize, bar, now we can call it a decorator. So I didn't want to use the term before because we didn't need the name before the concept. Now we can put a name on that concept and that syntax that allow in a declarative way to transform a function that we define just after that line. So this can be used to modify the definition of a function, but here we can do whatever we want. Okay, so we could have done any other operation here. Okay, so let's continue now. And what we are going to do is to use it. If we go back to my plugin here, so here we've used it, and so that means that this thing here might be something like decorators, but here what we have is that we have parameters that we passed there is another bit of a syntax there that we have to look at, and we are going to do it. So let's go there. I remove again this one. I don't want to remove it. So here, this is what we did. So a decorator here is a function that takes a function and return a function, but it can be something with a parameter here, so that takes any kind of parameters that is provided. When it is applied, when we apply that function to that parameter, we get a new function that then we apply with that function foo. And in Lightning, in the pyln, this is used to, so we are going to call it, this is used to modify a list inside the plugin, so the list of the method. So the function, sorry, so I hope I try to be clear, but maybe I hope I'm not messing with you. I'll try to be clear. So we can use decorator to modify function, but as in the core, in the body of the decorator, we can do anything we want. We can also add stuff to some list, and this is what we are going to do right now. So we are going to have a list that we call methods, and not a list. We are going to have a dictionary here. Make decorator. So we are going to make a decorator, and what we're doing is really a simplified version of what is happening and how the decorators are used in a pyln-client. So here we would have RPC method name, okay, and what we would have here is the definition of method function that take one argument, and that function is going to do something. So what can we ask it to do? Maybe we can just return, okay, so we are going to do something like that, foo and bar. So we return a dictionary with foo and bar, because and we don't care about, maybe no, we can do x field, and here we pass it x, okay, to use that thing that we have here. We are not passing the plugin there, huh? Okay, so to get to have the thing simple. And now we still have to define make decorator. So make decorator, this is something that we have something like that here. So method function will be redefined as we've seen previously, but this is Python that do it. We don't do this by ourselves. So, and we pass it my method, for instance, okay, to define, no, the one that we did before was my plugin. So we could do that. So this, when we run that, make decorator my plugins have a string argument, should return a function that take a function and that return a function. Okay, so make decorators is really that we take a parameter and we return a decorator, and the decorator we've seen before what it is. It is to modify the behavior of my method. But what we're going to do in the body of the decorator is that we're going to register in some way, and to add to that list methods, we're going to add the RPC method name and as a field, and this is going to be the value of that field. And because what it is done by the decorator, this is this. Okay, so the decorator, the syntax and the Python do something like that. Make decorator, take a parameters, return a decorator. The decorator is applied to the function that is defined just below the decorator, and we do stuff with that. And in the case of pyln, which is super funny, the function is not modified, and we just use it to add stuff to method. Okay, so I'm talking, and we are evaluating nothing, sending nothing to the interpreter, but I had to tell you all of those things. So maybe we can go there, and we have that. So when we copy stuff around, often mistakes happen, but anyway. So bar, now this is make decorator, okay, and it no longer take a function, okay, because it is taking a RPC method name. Sorry, here we did it now, my plugin, because this is a method that we want to do there. So just to go back, so the name that we have is my plugin. So this is the method that we want to do. This is what is done by Python. And here, when we define it, we give it that name, RPC method name. So here, now we need a function. So that this is a function that we are going to return here at the end, and that function is called the decorator. So as it is the decorator, it needs to take one argument, which is a function. So we take a function, and basically the function that is going to be taken is that one. Okay? Because this is really, at the end, the result here. Sorry. We are going to have that, and this is what is going to take that result. So here, we have to return the decorator. Okay, and now what do we do? So we are going to methods, and we want in the method to have that, and we want to give it f. So I hope I get the syntax right. But what we are going in the decorator, when we are going to apply it, we want to add something to the method, and the decorator, remember, is something that has to return a function. So here we can return any function that we want, and we could write something like lambda x blah 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 something. But what we return, because we don't care about modifying the f, which I recall you that the f is method function, we don't care about modifying it, because we really, this is a function that we want the user to define and use in the case of Lightning on pyln. So we return it because it works like that. But what we did is to add to the dictionary method, we add the name and the thing. So if we did something the right way, this should work. So we send method. Method works. So you follow with me. Now we send this one. So make decorator. It seems to have worked. And maybe let's just check methods here. So we have it, and it's empty. Okay, so we did nothing so far to that method. We define make decorator, and now if the syntax is right and we did the right things, we should have something working. And what do we want? We don't care about my method function that we know that normally hasn't changed, but we want to see methods, okay, and we want to see if we have something new. Cool. So what we have is that we add some things to this, and we can. I will continue there. Maybe I should have done it at the top, but we have this my plugin here, and this is a function, and that function takes some things here that we have. So the x field. Okay, this is the x here, and should return that. So we are going to pass it something that 9x, and this is what we get. So we get the that result that is exactly the results that we want from a method function that using that syntax we've added to method here that was empty at the beginning. So this is not exactly how it is done in pyln, but this is the way we can think about, because this is really that we are adding. So for instance, this is not a global variable. This is the method. That's not the method. The field of the object method that they are all there, and maybe we can just go here on my plugin. No, I want to go to plugin.p. So we are here in plugin.p, and we are just looking at method here, and the method is that. We'll go back to my plugin here to see the thing. So here, so plugin method, this is really the make decorator that we have in decorator. So we really have to think about here this syntax here. So this is make decorator. This is the thing that we have here. That is my plugin method, and we pass it something here, and the things happened. And if we go back to plugin, you can see how it is written. So there are a lot of types there, but it's not here. If we look at our decorator, we just take one function here, okay? And what do? We call add method here to self, and that method will do the right thing and add transform all that is here into a method object, and this will be added to the method of this object. We see here that we are returning f, so we really return the same functions that we have, and overall the method, which is a make decorator, return the decorator, and we can see here this is the thing that take method name. So this is for the two part that we did, and cool. We have 7 minutes to talk together. So if you have question, I really hope I was clear in that explanation of the decorators and how it is used by pyln. But it's really super. I love it. I love how they used it. I don't know if it's something that that is normal to do in Python the community, but it's you have decorators that allow you to modify functions, and it is used to modify the list of something in an object. So really cool. So question or commentary or maybe other things? Okay, so the question is, I'm not very clear on the kinds of things we use Lightning plugin for. So plugin, as far as I understand, is really part of the design of the software, and many of the features offered by Lightning are done as plugins. So, for instance, the command pay that you might have already used is implemented as a plugin. Splicing that are going to be live or are currently working on the in the pull request is also implemented as a plugin. If we can go, so if you see still that we can go here in the plugin. I will do the same thing that I did before. So I will do a read grep and get all the methods. So plugin. So you can see at the bottom plugin and method, and you can see all there 41 hits, and it is used in the plugin surround and currency crate, summary, data store. So you can really go there, and if you understand a little bit what we did today with the plugin with pyln, you have a lot of examples that you can go through in that repository where there are a lot of plugins written in Python. So you don't have to do the works of understanding how it is defined, but you can concentrate on what they are doing. For instance, let's go to the historian there, and you can see the kind of stuff here that they do. So you, as you know how things are presented, you can go there and concentrate on how to do what the things are and what are the possibilities. But you can do anything you can imagine, I think. Does this answer your question? Okay, so the repo is terminal. So you can see the repo here. Okay, so if there's no other question, maybe we can stop here. Drew, what do you think?
Tony, that sounds good. This is great. Thank you for doing this.
Okay, cool, great. Great to see you all today, and see you in 2 weeks for another one.
Awesome. Thank you, Tony. Everyone have a great day.